Okay. All righty. Welcome to our March 14th, 2025 general business meeting of the Amateur Astronomers Association of Pittsburgh. We welcome you with open arms. Thank you very much for joining us. I would like to turn this over to John Weskovich to introduce our guest speaker tonight. And we hope that you will join us later for our 3AP business meeting at the end of the presentation, which will begin at 8:30 p.m. John, are you there? I know you logged on. Oh, we must have lost him for a second. I wonder if he's having difficulties.
If you're chatting about me, yes, my laptop just crashed and I'm trying to join from my phone. That hopefully is working.
Yes, we can hear you.
Okay, awesome. Did Amruta manage to make it into the call?
I'm here.
Oh, perfect. Awesome. Okay, then let me see if I can switch windows and get your introduction ready.
Okay.
Okay, got it. All right, so welcome to Dr. Amruta Jaodand, who's an astrophysicist at the Chandra X-ray Center. She currently works in the director's office and is involved with the joint program management for the Chandra Space Telescope, as well as other multi-wavelength telescopes. Previously, she was a postdoctoral researcher in the New Star Group at Caltech's Division of Physics, Mathematics, and Astronomy. She did her PhD at the University of Amsterdam, works on observational investigations of neutron stars, and is very interested in astroinformatics, specifically cloud computing and machine learning for astronomy. And we've got a great talk about the Chandra Space Telescope today.
Thank you. Thanks for the introduction, John. I'm going to quickly start by sharing my screen. Okay. I hope you can see a blank screen right now. And now you can you see the presentation mode?
Yes, perfect.
Okay, great. And I'm sorry I won't be able to track questions coming in at the same time. So John, can you help me track those?
Yeah, happy to, as soon as I switch over to a different laptop.
Okay, great. Hi all. Thank you for being here. Good evening. It's good to see some of you back again. I remember giving a talk a while back to this group. Today we are going to switch track a little bit, and instead of focusing on my discoveries, I'm going to focus on one of the NASA's flagship mission, Chandra X-ray Telescope, go a little bit into the history of X-ray astronomy and discoveries that Chandra has facilitated over the last 25 years of its lifetime. So this is kind of a short bullet point time, line of this whole talk. And the whirlwind tour of Chandra discoveries is going to be intense, so I would request you to stay with me through that. If you have any questions, please feel free to open your mic and ask, or also you can, if you prefer to hold off your questions till the end, that's also fine. We can tackle them at the end of the talk. Okay, so diving a little bit into the history of X-ray astronomy and the timeline of how X-ray astronomy took center stage in the American space sciences. So when it comes to detection of different types of wavelengths, for example, optical, we can observe these kind of wavelengths with ground-based observations. There were calculations made as early as 1948 and theories existed for X-rays originating from the sun. And the spectral calculations that were made showed that the X-ray emission from this general corona and for typical solar coronal condensation. And here is a plot of atmospheric observation as a function of different wavelengths and where X-ray lies compared to optical and UV, etc. So on the y-axis, you can see the fraction of atmosphere any given wavelength would be able to have any given wavelength would be absorbed, or half absorbed by the atmosphere. And on the x-axis, you can see the particular wavelength that is being shown. I have also shown a quick plot of the altitude in terms of kilometer for the height at which a particular wavelength would be half absorbed. And that's also on the y-axis and mirrored on the right-hand side. Sorry, it's in kilometers. So you can see that the Mount Everest is kind of shown, and to give you an estimate of what heights are we looking at. So if we are around the height, if we are at about 16 to 17 kilometers from the surface of the Earth, where most of our airplanes fly, at that height, we are able to detect some of the IR emission, and radio emission can also be detected from the Earth. But if we are looking at X-ray emission, I don't know if you can see my whiteboard or not right now. I don't think so, right. So if we are looking at X-ray emission, we have to put our detectors at as high as about 130 or 120 kilometers from the surface of the Earth for those rays to be absorbed, to not be absorbed and to be detectable. And so what kind of options do we have at that point is, one thing that we can do is put our detector on some sort of a rocket and fly it for a very, very short time. And this was kind of an initial idea that they tested out. So this is an example sounding rocket called the Aerobee High. And these rockets were great because they were low cost and provided small flight opportunities to suborbital space. And they flew also at a pretty low velocities, and we could do short duration 5 to 20-minute flights. And the short time and low vehicle speed was more than adequate to carry out any sort of a successful scientific experiment, such as putting an X-ray detector on this rocket and trying to detect X-ray emission from the sun. The other great thing about these kind of sounding rockets was that these could be developed in a very short time frame, sometimes as quickly as 3 months. But still, taking an X-ray region photograph of a solar disk was pretty difficult because the low intensity of radiation and restrictions that were implicit in the X-ray optics. So the X-ray intensity increases from, as we know, from sunspots minimum to maximum. So what we really needed in these kind of X-ray detector that could be flown up aboard the sounding rocket was a small pinhole camera. And what this pinhole camera, you can see a schematic of this pinhole camera with an evaporated aluminum film in the back and the solar rays that could pass through the pinhole, and then the X-ray film in the background was exposed. And the image is smeared back and forth by the rotation of the camera about the Earth-Sun axis during the exposure in the flight. What that gave was this very first X-ray photo from the sun, conclusively showing that, okay, there is X-ray emission that comes from our sun. And the credits for this go to Richard Blake from Los Alamos. He's still working a lot as an amateur astronomer in the field right now. So this was the first ever camera picture of the sun. And this really cracked open the field of X-ray astronomy in the USA and the world over. One of the major players in this field was this amazingly talented Italian experimental physicist called Bruno Bernardetto Rossi. He made major contributions to particle physics and study of the cosmic rays, and was a graduate of University of Bologna. He was forced to immigrate and moved to Denmark first, where he worked with Niels Bohr, and then he moved to US and started working on the Manhattan Project. After the war, he moved to MIT and jumped back into pre-war research on cosmic rays. He was sure of it and sent the proposal. One sec. I'm sorry, I'm having a little bit of difficulty with my pointer. So I'm trying to just get that going. Okay, all right. Are you still able to see the presentation?
Now we see your desktop screen.
Okay.
Now we
so-
see the presentation.
Okay. All right. So yeah. So he was very sure of his research on cosmic rays, and he sent a proposal to the Air Force Cambridge Research Lab that, on the contrary to NASA, um, funded a series of rocket launches. During the rocket launch in 1962, at midnight, White Sands, they flew 3 Geiger counters. But before I go into that particular rocket launch, let me just quickly tell you why it was, why he could develop extra astronomy field so quickly. So there was a big Sputnik shock of 1957, which had accelerated space sciences and research in the US. What Bruno Rossi also did was recruit Giacconi, who is currently called the father of X-ray astronomy, to become head of the space science division. And he asked him to focus exclusively on X-ray astronomy in September 1959. Together, they filed 2 proposals in 1960, one for an X-ray telescope. I have in brackets shown that this kind of X-ray telescope is called Volter type, and what that is and how these telescopes work, I would come to that briefly. And then another was for a rocket to investigate the emission of X-rays from lunar surface. And this was the rocket that they launched in 1962 at midnight from White Sands, New Mexico. So this experiment, they wanted to study lunar surface X-rays. So these kind of X-rays would be generated by fluorescence from the lunar surface. And so they flew 3 Geiger counters aboard this particular rocket with a range of 2 to 8 Armstrongs. And based on the normal detector square sweep of about 55 degrees, they could obtain this plot. These Geiger counters counted the number of counts of the detections that they had received in different directions, northeast, southwest, and north. And based on this particular plot, you can see that there is a strong angular dependence of count range, count rate, and there are 3 different types of windows of thickness. So we have strong anisotropy, but then there are also very soft radiation. And the way we can see that is if you're looking at this plot, you can see where we particularly expect emission or the counts coming from moon. But then there is another strong peak that you can see around 183 degrees, around 195 degrees, that simply could not be attributed to the moon. And so this emission must be generated somewhere that is from a cosmic X-ray source. And in 2002, Giacconi won a Nobel Prize in Physics for this discovery, for his pioneering contributions to astrophysics, which led to the discovery of cosmic X-ray sources. Now, in 1962, motivated by this discovery, Giacconi gave a presentation in Stanford. And he put forth this idea of a 30-foot orbiting X-ray telescope. And this telescope, the schematic that you see on the right-hand side, was an initial prototype or sketch of an idea that today has become the Chandra X-ray telescope. From 1962 to a launch in 1999, of course, it took a lot of years. And there were several other X-ray satellites that were built in the meantime that kind of provided the technology maturation and mirror development that was required for Chandra to be realized. And in a way, it's kind of like, when you're trying to bake a pie because it's Pi Day today, you can't just bake a pie. You first need to perfect your crust, you need to get your fillings right, and then put them all together in oven. And with different types of trials, you'll finally one day have a really beautiful pie with filling bubbling to the surface, and it will be just the right kind of pie. That just right kind of pie is Chandra telescope. So the question is, what makes it so difficult to develop X-ray telescopes? one thing is that for visible light, which our eye is sensitive to, um, for visible light, which our eye is sensitive to, could you see the video? Sorry. Um,
Yes, we could see the video.
yeah, but yeah, we could detect the visible light much more easily. But when it comes to X-rays, they are extremely energetic. So that means that if you're trying to use the regular optics, say you're going to try and use a bunch of mirror to focus this light and actually take pictures, you would fail miserably, because instead of always being reflected off a mirror like a visible light, X-rays would go right through this particular mirror, as you can see in this video that I was trying to play, but I think it played for a very short amount of time. So because these rays would go directly through the mirror, we are not going to be able to observe them. This is also a great quality, which is why they use X-rays to scan human body, because they can easily go through our skin. So this is one of the reasons they had to develop a Walter 1 type telescope. But before we come to that, let's look at some of the other missions that were flown between 1962 and 1999, which paved the way for Chandra. One of the missions that was very critical was an Uhuru mission. Now, Uhuru in Swahili means freedom. And the reason it was named as freedom was that on December 12, 1970, was the 7th anniversary of independence of Kenya. And in recognition of the hospitality of Kenyan people, Marjorie Townsend, who was then the NASA mission project manager, named this particular mission Uhuru. So this was the first satellite that detected X-ray, that was dedicated to X-ray astronomy. It was also the first NASA satellite with a female project manager, Marjorie Townsend. Managed by the Goddard Space Flight Center, it returned groundbreaking science until the mission timeline ended in 1973. What this particular telescope comprised of, as you can see the diagram of the telescope here, was telemetry antennas and gaseous ionization detectors that you can see in this particular diagram. And the lower limit for the detection threshold was determined by the beryllium windows that were present in this particular mission. It flew in 96 minutes nearly equatorial orbit with two large proportional counter arrays and with an energy range of 1.7 to 18 keV, and offered a field of view of about 0.52 degrees. It was a pretty sensitive mission if you're looking at this mission being launched in 1970, and up to about 10 to the power of minus 11 ergs per centimeter square per second. You can see on the right-hand side the photograph of Marjorie Townsend standing next to the telescope to get an idea of how big it was. So this was, given its sensitivity and large field of view, it was one of the first missions to conduct an X-ray all-sky survey up to a sensitivity of about 0.5 milligram. And what this mission did was develop a map of X-ray sky that still is, in a way, a legacy map used in X-ray astronomy. This mission discovered about 339 X-ray sources. A lot of them are these classical sources that people study to this day, such as black hole X-ray binaries, some of the galaxies such as NGC 6624, then of course SMC, LMC, pulsar nebula such as Crab, and all of these were detected for the first time by Uhuru during its mission lifetime from 1970 to 1973. So after Uhuru came another mission, which was SAS-3, launched in 1975. This satellite was constantly spinning with 30-minute continuous exposure. And the idea here was that they wanted to now focus on getting X-ray emission from transient and periodic sources. And this mission also increased the energy range. So as you remember, Uhuru was about 18 keV, and the higher energy range, the higher end energy range for this mission is about 55 keV. And the best part about SAS-3 was that it could reach positional accuracy of about 15 arc seconds, so they could localize sources really, really well. And so, given the fact that it was constantly spinning, at a nominal 95-minute spin period, it could scan 60% of the sky just by its center lat. And this, this constant spinning ability and being able to rapidly scan the sky with 15 arc second positional accuracy provided for the first time precise location of about 60 X-ray sources in sky. So Uhuru had detected sources but did not have positional accuracy, and this is where SAS-3 came in and localized a lot of these X-ray sources. And it also discovered 10 sources that were going into outbursts during its lifetime. And discovery of outbursting systems such as AMHER and also Algol systems was facilitated by SAS-3. And it conducted, most importantly, study of the soft X-ray background that was present, given its ability to rapidly scan the sky. Now, this mission ended, and then the next one to come along in 1977 was the HIAO, which is the High Energy Astrophysics Observatory. It had a very heavy science payload. If you remember Marjorie Townsend standing next to the Uhuru, now compare a scientist sitting next to HIAO, and you can see how much larger this science payload was. So it was about 2 to 3 tons, and it could transmit information about 7 times faster. Again, think of it as an information being transmitted in 1977, and it was, even though 7 times faster, it's much slower than what we are able to do today. So HIAO-1 was a 93.5-minute satellite, and it orbited at about 432 kilometers. It had 4 science instruments with differing objectives. One of the main objectives was to conduct an even larger area sky survey. Second was to study cosmic rays. Third was to obtain celestial position measurements with an accuracy of about 1 arc second. And lastly, the objective was to have high energy X-ray instrument that extended all the way to hard X-rays. This payload was launched by Atlas Centaur rockets, and 15,000, basically this rocket had a 15,000 pound thrust second stage rocket that was designed for military in 1957 and 58 by General Dynamics. And it was the first rocket ever to use hydrogen technology developed by Lewis in 1950s. There were 181 successful launches for this particular rocket type, and one of them was the HIAO launch. When HIAO ended in 1979, it had completely blown open the field of X-ray astronomy, because if you remember that sparsely populated Uhuru sky map, now this is what the HIAO even all sky X-ray catalog looked like. It had discoveries highlighted in different colors, as you can see here, for active galactic nuclei, supernova remnants in blue, binaries that emitted X-rays in green. Then we also had clusters in pink color and stellar coronae, and of course there were a lot of unidentified X-ray sources. So this map shows 842 X-ray sources with very well-determined positions. And the particular mission here surveyed the sky 3 times over in a very broad range energy. Even today, this is unbeatable because it goes from 0.1 keV to about 10 MeV, and allowed for rapid variability studies in systems such as SIGX-1, helped us discover first eclipse in a low mass X-ray binary, and a QPO in a source, classical sources, just SIGX1. And not only that, it also did near constant monitoring of ecliptic pole sources and studied AGN X-ray emission and classified different types of AGNs. And finally, we could do optical identifications as well with HIAO-1. Its successor, HIAO-2, was launched in 1978, and although it had lower energy range, 0.2 to 20 keV, it was able to be the first mission to use focusing optics with imaging detectors. And so this focusing optics technology is the key part of Chandra's development as well. And this mission had spectacular angular resolution of about few arc seconds and a field of view of about tens of arc minutes, and sensitivity that was greater than 100 times of any previous X-ray astronomy mission, including HIAO-1. And what it allowed for the first time for NASA to be able to do is open up observing opportunities for anyone in the field of astronomy through a guest observer program. And when we are looking at the hit list of discoveries from HIAO-2, it was the telescope that provided first high-resolution spectroscopy of supernova remnants, coronal emission in normal stars, resolved lots of X-ray sources in Andromeda Galaxy and Magellanic Clouds, studied X-ray emitting gas in galaxies and clusters of galaxies, and detected jets from M87, provided the first medium and deep X-ray sky surveys, and discovery of thousands of serendipitous sources. The reason they're called serendipitous is that they were discovered as a byproduct of without being a targeted study. So this was the beautiful thing about this particular mission, is that it had the first focusing telescope, the idea that we talked about, the focusing X-ray telescope. And so what that is if you're looking at this telescope, you can see in the green color circle that there is a high resolution mirror assembly. Now, the way this high resolution mirror assembly functions is, if you remember from maybe physics classes, or that if we are looking at an incident ray, that is, if for example, someone holds a small light that incidents a ray from inside a water body, and so at the bottom you can see water in blue color. There is a normal surface. There is a surface that separates air and water, which is at the boundary of the blue and the white color areas. And so there is a particular associated refractive index for each of these mediums. So water has a refractive index of N1 and air has an index of N2. Now, if someone takes a small light and shines it from inside the water towards the surface which separates water and air. Now, if it is incident at an angle of θ1, you can see that if, based on this, the refractive indices N2 and N1, if θ1 is less than a certain value, you would see a ray of light emerge onto the other side in the medium that is air at an angle of θ2. Now there comes a critical angle called θc that you can see in the second schematic. If you incident light from within water at this particular angle, the ray of light would not be able to emerge on the other side in the medium that is air, but instead it becomes completely parallel to the surface that separates air and water. Now, if we exceed this critical angle of incidence, as you can see in the third picture here, with an angle of θ1, the ray of light does not even remain parallel to the surface, where it gets completely internally reflected. And this is the basic idea when it comes to this high resolution mirror assembly. So now think of lots of mirrors, as you can see in the schematic here, in black color, that have been arranged in a way such that we have one stack of mirror at at a particular angle, and then we have another stack of mirror that, with respect to that stack of mirror, has been oriented with a little bit of tilt. Now, if we have parallel high energy incoming X-rays, we had seen that if we put a mirror in the path of these X-rays, they would pass completely through the mirror. Now, if we place mirror assembly, as you can see here, and we arrange them such that the light that's coming in is at an angle of this critical angle or higher, then the light would be completely internally reflected, and we can try and focus it at a focal point. And this video shows that idea. As you can see, the light comes in, we have these two different stacks of mirrors, and the light gets completely, totally internally reflected. So instead of being this parallel beam that passes straight through, the light gets completely focused at a focal point in the back, as you can see, and it allows us to develop an X-ray picture in the background. And so this is the key technology, that focusing technology, that was at the heart of Bolter 1 type of mission that was proposed as early as 1960s and then became Chandra. Chandra, by the way, I've been going on for quite a bit, so if anyone has questions before we move on to the next part, please stop me and feel free to ask the question. And if there are no questions so far, we can look at them towards the end of this talk. Okay. Going once, going twice. All right. Yeah, so Chandra was launched in 1999, and it was deployed in orbit by the Space Shuttle Columbia. This is the most sophisticated X-ray observatory built to date. Chandra is designed to observe X-rays from high-energy regions of the universe, such as remnants of exploded stars. And to this day, it boasts of one of the most unprecedented spectroscopic and angular resolution. It was also a first in the sense that it was the first mission to be commanded by a woman, Irene Collins, who commanded the mission STS-93 that carried Chandra to space. So as you could see, STS-93 carried Chandra in its belly. This is the focusing telescope. And as you can see, to get that focusing range and to be able to get the rays focused at a point where we can develop a picture, we needed a pretty long focusing area of the telescope that you can see was about 30-meter long. So Chandra was deployed aboard from Columbia at 11:47 UTC. The initial upper stage was ignited at 12:48 UTC, and after burning for about 125 seconds and successful separation, the second stage ignited in 3 minutes at 12:51 UTC and burned for about 117 seconds. Now, if you look at Chandra, why we needed such a powerful space shuttle to launch it is that it was about 50,161 pounds. It was one of the heaviest payload that was ever launched by the shuttle. After the launch, we had to wait quite a while to get the first light picture. Its data started coming in photon by photon nearly a month after the launch. And we had no idea between the launch, this whole month, it was an excruciating agony because we had no idea where in the sky we were actually pointing. But we at least were getting photons, so that was good. And then very slowly, as the X-ray source became clear through the noise, as you can see this X-ray source, as we are accumulating more and more photons, it started becoming pretty clear that there is a particular X-ray source called Leon X1 in this image. Its size matched the expectations, and that sealed the deal. The telescope was good. it was in space, it was observing X-ray sources as we had intended. So if you're looking at the schematic of Chandra, um, I was talking about we need a really long focusing tunnel, and that focusing tunnel is called the optical bench that you can see in this image. And then we have different types of detectors that are present as part of this mission. So we have ACES and HRC, and what those are, I will also get into those details in a minute. So this schematic basically shows the mirrors with 4 science instruments. Incoming X-rays are focused by the mirrors to a tiny spot towards the end. And how tiny is this spot? If you had to get an idea of how tiny, it's as wide as a human hair on the focal plane. So we start getting X-rays incident from about 30 feet away. And then when they're focused to a small point, that spot, we have to get it as precise as a human hair's width. So what that meant is that the mirrors that we had to put in this optical bench and the mirrors that had to be developed would have to be some of the best and the smoothest mirrors ever built. They had to be exquisitely smooth. In fact, they are the smoothest telescope mirrors within 2 angstroms. So if Chandra mirrors were blown up, for example, to the size of the Earth, the very biggest hill or anomaly that would be on this mirror would only be 5 foot, which is an average teenager's height, let's say. And so this 2 Armstrong width that we had talked about how well-built these mirrors were, actually translates to only about 12 centimeters, not even 5 foot. And so the mirrors on Chandra alone at that point in 1999 prices cost about $500 million, which, let's adjust for inflation, it's a pretty expensive telescope, and it would require a lot of things to come together for us to be able to develop a mission like this again. And it carries different science instruments called advanced. One of them is ACES, which is the Advanced CCD Imaging Spectrometer. And the other one is a high resolution camera, or HRC. In this image, you can see what is the field of view for each of these instruments and how different detectors are arranged in ACES and HRC. So ACES, to say it simply, is an X-ray imager. What it does is it conducts high-resolution imaging, and it takes images of the space with about 1 arcsecond spatial resolution. And it can also be used to conduct spectroscopy of celestial objects and to conduct variability studies or timing studies of these objects. However, this instrument layout, which is shown to the right, it has lots of different chips in the CCD. And these chips are illuminated differently to obtain or play around with this, obtaining the best spectral resolution. Now, let me show you a quick diagram of how this works. We have incident X-ray photons. Chandra's detectors record both position and arrival of time of these incident X-ray photons. And then as you can see on the right-hand side, we develop a plot of occurrence of these X-ray photons that are hitting the camera at specific CCD, and use that information to get pulse height and develop the position, energy, and arrival time of where exactly this X-ray photon that hit the camera came from, and how energetic it was, and at what exact time was it incident. So that gives us a lot of information of which source does this photon belong to, and at what time do we obtain these photons. And if we keep obtaining a lot of these photons from a particular direction, from a particular source, then we can start conducting variability studies for that particular source. Now, the other camera, that is the other instrument that is a part of Chandra, is the high resolution camera. And what it does is it detects X-rays reflected from an assembly of 8 different mirrors. And the reason this particular instrument is so unique, so we have some stats of this particular instrument. And if we use it in different types of configuration, so science mode, if we use it as a high resolution wide imaging instrument or high resolution spectroscopic instrument, or if we use it in a particular mode called timing mode, we get different fields of view, different energy resolution. And most importantly, the reason HRC is so great is we can obtain really, really precise time resolution all the way up to 16 microseconds. So it allows us to study some really rapidly variable sources, such as the ones that I work on, called neutron stars that rotate about 1,000 times a second. And it allows us to study what causes these objects to get up to those speeds. So one of the quick, really wonderful detail about this telescope instrument, HRC instrument, is that it can make images that reveal details that are about as small as 1/2 an arc second. So if we translate it, this basically, somebody is able to read a newspaper while being seated about 1/2 mile away from this newspaper. So that is how precise this particular instrument is. And it also has a spectacular timing resolution in the timing mode of about 16 microseconds. So it allows us to study sources that are rapidly variable. I'm going to skip the description of everything that HRC does. But apart from the fact that there are these 2 particular instruments, there are also 2 different gratings, the high energy and low energy transmission gratings that are present, which allows us to combine these gratings with instruments to be able to use the telescope in different types of modes. And that gives us the 4 different usage configurations for the telescope. Now, the Chandra has been operational since 1999. So last year, we celebrated 25 years of amazing science that is being enabled by this wonderful flagship mission from NASA. And one of the most beautiful thing that you can see is through different discoveries that this telescope has enabled. And one of the first things that I would be talking about is stellar and planetary birth and how Chandra has changed our understanding of this particular field. So if we are looking at this image from Hubble Space Telescopes, peering into a stellar nursery. Now, with an optical data alone, we can see hundreds of stars that are present in this particular obscured nebula. If we start using X-ray emission and X-ray resolution images, which are from a telescope called ROSAT, as early as ROSAT, if we are focusing at the center of this particular stellar and planetary birth nursery and get an X-ray emission from this particular center, we can already say that all these sources are not obscured, but instead there are some unobscured stars that must be present in this area. So this was a discovery made in 1995. Now, once Chandra came on board and started observing this particular stellar nursery, in 2005, they put out a picture of what would happen if we took Chandra and allowed it to look at this particular region of the stellar nursery. And here is an image in 2005 from Fagelsson et al., looking at that exact same ROSAT image. And what we can see are hundreds of obscured stars are now being seen. And these are able to provide a census of young stellar members of this particular cluster. And we are not only able to do that, but we can also detect significant variability in these sources, giving us an idea of how stellar nurseries produce different types of objects and how many different types of source populations exist in these regions. And that really changes the fundamental view of how stars are born and how planets are born and how the regions that produce them operate. Chandra has also looked into our own galactic center, and this is a panoramic X-ray view that covers a very massive region, 900 by 400 light year swath, and shows the center of the galaxy. It's a place that is teeming with lots of different types of objects. There are, if we focus on a small portion of this particular region, we can see that there are objects such as supernova remnant point, SNR 0.9.01 on the leftmost side of this particular focused region. But not only that, there is Sagittarius A East, which is towards the center. There are also many, many bright X-ray sources, which we believe are binary systems or pairs of orbiting objects that can contain black holes or neutron stars, which are extremely dense stars right after the black hole, some of the densest stars. And so these binaries, highly energetic binaries, can also be seen towards our galactic centers. And we also have hundreds of unnamed point-like sources that are maybe white dwarfs, which all light up this particular region. In addition, there are also massive stars and other clusters that you can see in this particular image. And some of the stars that you see here will also soon explode to become supernovas, then driving birth of newer black holes, newer neutron stars. And all of this tumultuous activity, all this commotion that is taking place in a diffuse cloud of hot gas that is shown here because of its extended X-ray emission that it puts out. The diffuse X-ray glow that comes from our galactic center is pretty bright, with Sagittarius A, which is one of the brightest blob in the center. And it is a remnant of a supernova that stirred things up about 10,000 years ago. Then Sagittarius A West is a spiral-shaped structure of gas that is falling towards Sagittarius A towards the center, and the supermassive black hole that sits at the center of the Milky Way galaxy. Sagittarius A star that you can see here contains about 3 million times as much mass of the sun. I'm sorry, I'm not able to use my pointer, but if you can see, I'm talking about the Sagittarius A, which is in the center of this image. It's about 3 million times the mass of our sun and is gaining weight as it accretes more and more material because of the gravitational attraction. And Chandra has also played a key role in supporting Event Horizon telescope imaging of this particular region of this supermassive black hole at the center of our galaxy. So I don't know if you remember, a few years ago, there were these pictures of black holes that were released by EHT. And one of the critical data set that has come into play came from Chandra to build this interferometric image. So you can see the radio picture. Now, the next field that Chandra has completely changed our understanding in is the study of supernovae. So I briefly mentioned that our galactic center has lots of stars waiting to go boom, waiting to go supernova. Now, one of the supernova that was seen and there is a record of was seen by Chinese astronomers as early and as the year 1054 and recorded. So this particular supernova left behind a remnant called Crab Nebula. And Crab Nebula is about 6,500 light years from our Earth, and at the center of it sits a neutron star. So neutron stars are super dense compact objects, second only to black holes in space. And here is a really beautiful visible light image, stunning image that's captured by Hubble Space Telescope. It shows us the fascinating remnant of a massive exploded star. But what when we take Chandra picture of the same exact supernova remnant, we get a very different image. What it looks like is a ghostly wasp uh, with a neutron star at the center, with ultra strong magnetic field that heats and energizes all of the surrounding material that was being seen in the HST image. And also, this magnetic field is propelling lots of energetic particles. So, what Chandra allows us to do is track the neutron star, the compact object that sits at the center of a supernova remnant. And this is the most beautiful thing about when we talk about fleet of observatories, fleet of NASA observatories. What they allow us to do is build a complex picture of 3D pictures of different objects by looking at the same object in different wavelengths. So this is a crab nebula's picture with data sets that are coming in from radio telescopes such as VLA in red color, Chandra data in pink, Spitzer telescope in Spitzer mission in yellow color, Hubble Space Telescope in green, and XMM, which is another X-ray mission, highlighted in blue color. And when we put all of these data sets together, we are now getting an idea of not only what do the surroundings of this particular object look like, but what is driving the energetic emission, which is the neutron star at the center. How is it able to do that? How is the surrounding material being heated and energized throughout its lifetime? And not only focusing on one particular supernova remnant, but Chandra is a supernova remnant machine. It has also looked at lots of other such objects. Here is an optical view of one of the other supernova remnant, Cassia, obtained by Hubble. And then this is a radio view obtained with Very Large Array in New Mexico of the same object, Cassia. Now, once we bring in Chandra along with the radio image and the optical image, this is what the X-ray view of Cassia looks like. So again, we are able to see the supernova remnant score. And this is the first light image of in X-rays of this particular object that shows that probably there is a neutron star sitting at the center. And the composite view, as I had promised, with Chandra and VLA and Hubble, shows us the complete breathtaking picture from the center to the energized surrounding. And if we look at why Chandra is also critical when looking at such kind of highly energetic object is that we are also able to do spectroscopic studies. These spectroscopic studies help us understand what is the composition based on the spectra of the particular object, what are the different emission lines and absorption line, and what do they point to in terms of the composition of this supernova remnant. So this remnant is comprised of silicon, sulfur, calcium, iron, based on the spectroscopic studies. And that is also really fun that we are able to look at chemical composition of different energetic surroundings in these SNRs. So Chandra's sharp X-ray vision allows scientists to determine both the amount and location of where exactly each of this crucial element is being produced within a supernova remnant. And this is an image or infographic that will show how Chandra is also able to not only get time-stamped snapshot of these objects and help us understand energetics of these particular objects, but it's also able to go back to them over the course of its 25 years of lifetime again and again, and then show the clear changes that occur in these objects. As you can see how the neutron star is blowing the energetic emission or how it's shaping the surroundings in both the objects. And we can see not only the neutron star, but we are also able to see changes in both the ring of the ring and the nebula over this timeline of 25 years. What was one of the fun thing is that uh, looking at Crab with Chandra, we could also see the passage of Titan in front of Crab Nebula in January 2005 over a period of several hours. The next time this phenomenon happens, where Titan will pass against the backdrop of Crab, would be 2267, long after all of us would be gone. One of the other amazing fields where Chandra has made a significant contribution is the discovery of gravitational wave emission counterpart in X-rays. So gravitational waves are ripples in space-time generated as two compact objects, such as two black holes or a black hole and a neutron star or two neutron stars, merge and smash into each other to create a remnant, such as another black hole or a very short-lived hypermassive neutron star. One of the first such events that was detected was in 2017, detected by gravitational wave interferometric observatories such as LIGO and Virga. Now, there are popular theories about what kind of electromagnetic emission should arise from each of these type of binary mergers. So if the two black holes are merging, what do we expect to see at different wavelengths as follow-up to this merger being detected by interferometers? If we are able to see a black hole and neutron star, then what would the energetic emission in different electromagnetic wavelengths would look like? And then thirdly, if two neutron stars are merging, we expect a different kind of electromagnetic emission. And of course, all of these emissions have their set timelines, which is what points out, okay, the merging object must be a black hole and a black hole, or a black hole and neutron star, or two neutron stars. So based on when exactly do we see this emission, how energetic it was, what did the spectra look like, how did it evolve over a period of time, we are able to try and understand what these objects that merged look like, and what were their surroundings, So X-ray emission from one of these first such detected merger of two neutron stars, gravitational wave 170817, as we called it, initially, there was no X-ray emission that was observed. There was a lot of optical emission that people had observed, UV emissions, some early time IR observations as well, but no X-rays. And then X-ray emission started brightening from 7+ days, a week after gravitational interferometers such as LIGO had detected this merger. This was one of the most intense electromagnetic campaign to chase electromagnetic counterpart to this merger that was ever organized. And what the X-ray emission showed, the fact that it was observed 7+ days after the initial merger, is that there must be a really strong jet that somehow slowed down and became wider. It became wider in terms of what was the opening angle of the jet as it impacted onto the surrounding gas and dust. Now imagine these objects are merging at a megaparsec distances from us, and we are able to study their surroundings. What would they look like, or what is driving these objects to merge? How are these populations that are merging? How do they originate? Based on X-ray emission, because it gives us the information of surrounding gas and dust. And these surrounding gas and dust, as I mentioned earlier, slowed down and widened the jet. And these changes, the slowing down and widening of the jets, caused an increase in X-rays that was observed by Chandra in 2017. So here is one of this illustration of a merger that you can see that the X-ray emission that was observed after 7 days continued to be observed by Chandra as long as 4+ years from when these objects had already merged into each other. So this continued observation showed X-ray emission remained nearly flat. So this is kind of what the illustration shows, the surrounding medium um, around this particular merchant would have looked like, what kind of shocks must have come through. So you can see the two shock fronts as well in the illustration. Um, and so Chandra has made a huge dent in the study of electromagnetic counterparts to gravitational wave objects. And lastly, and most importantly, is that because Chandra has been looking at the X-ray sky for the last 25 years, now you remember Hiao, you remember Uhuru, and all of these missions. Sorry, I think I just got some sort of message here. Okay. And now Chandra has been able to revolutionize the X-ray astronomy field, and we have Chandra source catalog, or that comprises of, if you remember, PIA1 was 800 and something sources, and we were already blown away by how many sources we had. But now Chandra 2.0 catalog hosts 407,806 unique, compact, and extended X-ray sources with more than 1.3 million individual detections. This really opens up the discovery field for X-ray astronomy. And there is these large and rich data sets need efficient and automated approaches. So people are now using techniques such as machine learning based approaches to try and classify all of these objects to study ones that have been serendipitous discoveries. And a lot of these tools are also being developed by the Chandra community, which is going to be a large legacy product that remains long after Chandra is also gone. So to highlight, there is a new data revolution that is brewing in astronomy. And a lot of the time people think of it only happening in the optical space with maybe LSST, or happening in IR, or radio with SK. But while these surveys are able to stretch the boundaries of astronomical data, X-ray surveys are not far behind, and what they are able to provide is a unique view where we are able to see the compact objects, we are able to localize them with Chandra. And this way, this legacy data that we get from Chandra can be combined with JWST, can be combined with LSST to obtain very valuable information of lots of different types of sources. So I will leave you with this big slide. What has Chandra seen? Has it seen it all? And what kind of discovery space remains in front of us as we step into the future of Chandra? Thank you. Okay.
Thank you so much. I was going to say, I think we might have maybe a question or two, maybe. I saw some hands going up.
Okay.
Joe, did you have a question? Maybe. Okay, maybe he was just raising his hand to say,
No,
great
I'm sorry.
job.
I did have
Oh,
a question.
Oh, go ahead.
When you see like two neutron stars or a neutron star and a black hole merging, how do you know where to look? Do you just see them from doing some sort of survey, or do you have an educated guess on where to look?
Yeah, that's a great question, actually. So when we observe, or when we detect disturbances through the gravitational wave strains in interferometers, we don't really have a great location. The best we would have is if we use multiple interferometers, for example, a network of interferometers with one based in Hanford in the US, another one in Livingston, and a third one that is based in Italy, which is Virgo. What the best we're able to do is triangulate a source and say it should be detectable within this, in the 95% confidence interval, within these 1,000 square degrees. Now, 1,000 square degrees, looking at that region, or even like 50 square degrees in space at megaparsec distances, it's really beyond finding a needle in haystack. It's finding a very, very tiny dot. which is present on a needle somewhere. So the way people are able to identify where this source might be located is that there are lots of optical collaborations, optical, for example, a collaboration that I was a part of at Caltech was called Growth Collaboration. And what this collaboration had was a network of telescopes spread across the earth, all the way from US, India, Europe. And these telescopes would start looking at that particular footprint region of 60 square degrees to try and identify sources that are brightening and had temporal coincidence with the particular merger that was detected. And they were trying to see sources that were brightening rapidly, showed a particular type of optical color as time passed within the next 24 hours, 48 hours, and tried, and then of course, this generates hundreds and hundreds and hundreds of possible associations in this region. So what is also done is a clever cross-match of the sources that they have detected in optical with a maybe neighboring galaxy or maybe an associated galaxy to try and locate galaxy associations and provide some kind of confidence on these objects, which is why we need a lot of optical observations. And then optical observations are followed by other wavelengths to see the strongest candidates that were observed, how are they evolving now, 4 days, 3 days, 5 days later. For example, X-ray association 7 days later is one of the strongest ways we can say this is definitely coming from one of these associated candidates. And so this must be it within this particular footprint region that we have. So yeah, it's really a big chase once you get a detection.
Okay, thank you.
Yeah. I think
All right, Eric, you had your hand up.
I'm not able to hear Eric.
Eric, did you have a question?
That's funny. Oh, okay. Now can you hear me?
Yeah,
Now, very
now I
quickly,
can
I know
hear
we're
you.
running out of time here. You may remember when Chandra was launched, the space shuttle had some problems going up. The error messages started popping on the screen, and Eileen Collins was having a nerve-wracking ride to orbit.
Yes. Yeah.
So I wondered if you experienced that nerve-wracking stuff. Maybe you didn't at that time. So
Yeah. So I was 80 years old in 1999. But Eileen Collins was actually here to celebrate the 25 years of Chandra with us. And she gave a great talk and a panel, and they had a massive panel discussion where they brought up this particular thing is where they started seeing these messages and errors that were popping up, and they had no idea at that particular point of time how to deal with them. And it was amazing to hear that whole story of how those 3 minutes were completely nerve-wracking for the whole crew about what was going on and how they powered through that whole episode.
and I have, my very quick question is
Yeah.
Chandra far enough from Earth that there's no risk of re-entering the Earth's atmosphere? Is it at a far orbit?
Sorry, Eric, can you repeat again, please?
Yeah, is Chandra far enough from Earth that there's no risk of re-entering the Earth's atmosphere?
Yeah, so Chandra is at an altitude of about 140,000 kilometers. I was quickly trying to convert it to miles just now. And so that is about 86,500 miles in a highly elliptical orbit. And so given the fact that it's at this particular orbit and the altitude, we don't have the risk of its re-entry soon. But of course, and so the mission timeline is not going to be determined by that particular concern of re-entry.
Thank you.
Yeah. Anyone else? Okay. If there are not a lot of questions, I can also leave my email. And if you have any other things you would like to discuss, I would also send over Eileen Collins' interview that we had recorded and a YouTube video about the launch of Chandra, which is very fascinating to watch with the whole STS-93 crew. So if anyone is interested, you can also look at their whole story from this UTC 1241 to UTC 1251, the 9 minutes of launch and separation and getting Chandra in orbit. So I would send that over just in case someone is interested. Okay, great. All right, thank you. Thank you for having me, and sorry if I powered through a lot of information today.
No, it was great. Thank you so much. I definitely enjoyed it. I'm sure a lot of us, like with the astronomy club, a lot of us have different interests. So it's fascinating to me. I was trying to turn my mic back on. If you don't mind, if I just ask a really quick question. So since, the launch was so long ago, and to be honest with you, the pictures at the end of your slideshow are like, they're just amazing, especially when you are combining like the newer technology with that, like, with the Hubble and everything else. So how are they like somehow updating that technology with the telescope, or is that from the original that was launched, just out of curiosity? Because I'm sure, like, since it's been up there for so long, like, I'm amazed by it. It looks fantastic.
No, it's the original mission. We don't have, unlike Hubble, we've never had, kind of operation to go replace anything on Chandra or correct this flap or anything like that. So all of the pictures that you're seeing is with the help of technology that was developed in 1980s, 1990s. But they thought so ahead of their time, and they put in so much effort in the development of this particular mission that even now we're getting these spectacular images. Of course, I think the next step would be if we someday have another follow or, kind of next Chandra 2.0, or a similar mission that is going up there. And there are some ideas that are in consideration that will give us a big chance to update the technology and update the possibilities of getting higher localization, positional accuracy for sources as well. So, yeah. Phil has a question as well. Phil, I think you're muted. I'm sorry.
No, I'm sorry. Sorry about that.
Yeah.
I was impressed with the surface of the mirror in there, and I was just wondering what company it was that produced the optics for that telescope.
That is a good question. I actually don't know, but I think it was Raytheon that had developed the optical systems, but I don't know which company exactly developed the Chandra mirrors. I am going to try and find that out and get you that information.
Thank you anyway.
Yeah. The other thing that I was trying to get for everyone is of course, Chandra has a massive library of all of the images it has taken and all of the beautiful objects that it has observed. And I was just trying to link that in the chat. So anyone who's interested can go through this massive library and see any sort of images that you might be interested in. One of the last thought I would leave everyone with, it's kind of fun to talk about Chandra because Chandra in Sanskrit means the moon on the day that we have lunar eclipse today. So yeah, I don't know if you all have also, you're also planning to go or talk about that in the meeting today as well. So yeah. All right. I think that's my cue. Yeah.
I was going to say,
Yeah.
yeah, thank you so much. And, if you don't mind sharing your email. John, I'm sure, has it as well. If any of our members have further questions or would like some more information, if you are fine with them reaching out, that would be fantastic. And we see your link for the pictures. So I'll make sure that we copy that. Oh, and there's your email. Thank you very much. So we'll make sure we copy those
Yeah.
so that I'm sorry. I think
Okay.
you're, oh,
Okay, I was just saying, yeah, I'm breaking up for some reason, right?
that's okay. But yeah, I'll make
Okay.
sure we share that with everybody. So,
Mm-hmm. Yeah, great.
all right.
And so, yeah. Awesome.
Oh.
Okay. Thank you all for
Thank you.
having me. And it was great seeing you all again. Bye.
Excellent talk. Excellent talk. Thank you.
Thanks.
Yes, thank you. All righty, guys. We'll go ahead and take a couple minutes to, take a break, get a drink, whatever you got to do, and we'll reconvene for the meeting. Thank you very much for joining in for the presentation. I hope you guys will stay for the meeting as well. And yeah, we'll take like a 5-minute break real quick. All right. Awesome. All right. Well, welcome back. I hope you all enjoyed the presentation. And thank you again for joining for our meeting tonight. For those of you that are on YouTube, please like and subscribe to our YouTube channel. We do have 2 more meetings before we hit the summer months, and we'll be posting hopefully some more tutorial videos and also presentations. So please click that notification bell so that way you can stay in tune with us. So we're going to go ahead and get started. So it is 8:56 p.m. I know we went a little bit over, but I am going to go ahead and call this meeting to order. So let's go ahead and get it going. All righty. So our last meeting was on Friday, February 14th. Of course, that was on Valentine's Day. Rich, would you like to go over the minutes from that meeting?
Yes. Summary of the February 14th, 2025 business meeting. Meeting was held online, hosted by Google Meet and live streamed to YouTube. Meeting began at 7:30 p.m. with a presentation by Dr. Adine Denton, currently a postdoc at the Southwest Research Institute. The title of the presentation was Sealed with a Kiss, the Cosmic Romance Between the Formation of Pluto and its moon, Charon. The meeting was called to order at 8:50 p.m. by President Kristen Crawford. The minutes of the last meeting were read and unanimously approved. Motion to accept by Tom Pfeiffer and seconded by Phil Breidenbach. John Holtz gave his look at that presentation with some highlights, including Venus being at its brightest on February 16th, Antares and the moon being close on the morning of the 21st. March 1st, we'll have the moon and Venus close. And of course, the total lunar eclipse on March 13th, finishing on March 14th. Board report. John Wenskovich, Vice President, the March speaker, was unable to present. So he needed speakers for March, April, and May, but I believe he has filled those slots. He can fill that in on his report. Nothing new to report from the recording secretary. We did start the VA observation nights, and the offsite party was filling up rapidly. Dave Rager had a steady stream of inquiries from the public via Facebook and the club website. Terry Mealy, Treasurer, and Michael Scoverin, IT, were not present. Joyce Osborne Fisher, GuideStar editor, put out a request for contributions to the GuideStar. Doesn't have to be written. If you're not confident with your skills, just an outline, a rough draft, and Joyce will polish it for you. Membership Secretary Gail Rigger wants to remind people to use her address found on the website for memberships and not the club PO box. The list of new members since January 11th, 2025 was presented and voted on. Motion to accept by Joyce Osborne Fisher, seconded by John Holtz. Motion passed unanimously. For the Wagman report, Director Eric Fisher reported that there was now a combination lock on the Wagman gate. They had 3 companies lined up to get a bid for repair of the wooden floor in the Brashear room, and that they would be scheduling a spring work party early March. For the Mingo report, Director Brian Crawford thanked everyone who helped with the first work party at Mingo. Also, there will be several more over the next couple months. The 3AP is listed on the niche site as vendors, and there have been several planning sessions for our booth options. And we still need, and this is ongoing, so if you're an astrophotographer and would like to submit an image to the club for promotional materials for NEAF and other promotions, we're going to have postcards printed with the members' photos. Please submit those to Brian. Club calendar is up to date with the dates and times for star parties. The deadline for membership renewal has passed. Anyone who didn't renew by January 31st had been removed from the listserv and Discord. Still looking into opening a storefront and the tax landmines involved. As for new business, Ken Coles extended an invitation to 3AP members to come to IUP for a planetarium show and possible stargazing in April. Details were later sent out via Discord and the listserv. Again, the 100th year anniversary for the club is coming up soon. Any members have thoughts and ideas on how to celebrate, please share. And motion to adjourn by Eric Fisher with a second by Rich Dawlish, unanimously accepted. That's it.
All righty. Thank you, Rich. May I have a motion to accept the meeting minutes from February 14th, 2025? Patrick, I saw your hand went up. And Lish, I see your hand went up, so I will take that as a second. All those in favor, raise your hand, say aye.
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 All right, are there any objections? Any abstains? All right, motion passes. Thank you all very much. All right, so I will turn this over to John Holtz for our look at that. I'm excited to see if we got some pictures from last night. I tried to look on Discord. I had a very busy day today, but excited to see. And John, I'll stop sharing, or maybe will it let you? Oh, there we go. Okay. I didn't know if it lets you do it while I was up here. Okay, perfect.
I didn't know either, but it did. So we'll go with it. So here's some upcoming events. I can get my presentation up here to click on it. Here we go. All right. Interesting that on St. Patrick's Day, this March 17th, that's when the day and night are equal, even though the equinox is on March 20th. On the 22nd, if you're up early in the morning, take a look at the moon, and in particular, which constellation and where it's located at, because the moon is currently, at least on the 22nd, will be very far to the south, and it'll be just above the spout of the Sagittarius teapot. March 23rd, Venus is at inferior conjunction. So as Eric mentioned, or I mean, Joyce mentioned in the guide star, Venus is doing its rapid dive. And even though just a few days later, on March 27th, you can try for Venus in the morning sky. The moon may help, even though they are both very low above the horizon, just about half an hour before sunrise. And Venus is far to the left of the moon, 22 degrees or so. Mars is again heading towards Pollux on the 30th. It'll be 4 degrees south of it. Watch how it changes and let me know when Mars, Pollux, and Castor are in a straight line. April 1st, the conjunction of the moon and the Pleiades. It's always spectacular in the spring when you get a nice crescent moon. Jupiter and the moon and Spica will be very close to the moon on April 12th. We do have a number of photos. Aaron got the Seagull Nebula. Nice little smile on the bird. Ish got a photograph of M45, the Pleiades. Nice nebulosity. Connor got M42 and the surrounding nebula, and I see there's a streak here. I don't think that's quite the right path for a geostationary satellite to have been passing through. It's probably just another random satellite. Rich has a C-star telescope slash camera. Got a nice photo of M35 and Gemini. A couple photos from Pat. Here's Jupiter, and I don't remember which moon that is, but here you can see the red spot if my mouse shows up. I don't know if it's showing up in the transmission or not. And then a nice image of the sun. And here's the eclipse. Whoops, nope, sorry. This is not the eclipse from Aaron. This is not the eclipse from Lewis, sorry. Nope, not the eclipse from Brian. Sorry about that. Here we go. At last, we got an eclipse photo. Nice kind of reddish color, rosy color, a little bit more towards the red than what it was for me visually. And George Chase also has a similar photo where it's a little more reddish than orange. Nice photo from John. At least I think it's a photo. It almost looks like a watercolor image, perhaps. But this is getting more into the colors that I was seeing naked eye. Nice one from Owen and from Connor. And this is very reminiscent of what it looked like to my eye, with nice orange color, bright limb on the top. It remained fairly bright throughout the entire time of totality. And then Matt Jones, come on. There we go. Matt Jones put together a montage of the entire eclipse process. Now, before I open the floor up to other observations, let me talk about my observations of the eclipse last night. I'm going to use Connor's photo because it has the star field to the upper right of the moon, made this little Y-shaped constellation. And using my pocket sky atlas, I was able to see the 4 stars in this Y asterism and compared that to my star charts. And this is approximately where the ecliptic was, the green line. But something is not quite correct, because all of these images that show what the eclipse was indicates that the moon was north of the ecliptic, not south of the ecliptic. And the photograph confirmed that, because the bright limb of the moon was on the north side because it's closer to the edge of the umbra. So something was going on, and it's a little surprised that I was even noticing this at 3 o'clock in the morning after only a couple hours of sleep. But anyways, today I looked up on Stellarium and confirmed with these other fainter stars that were also visible to the left of the moon in Connor's photo. I confirmed that the line of the ecliptic that I have drawn is pretty accurate. So the question is, why was the moon south of the ecliptic in our skies? Well, what I did is I did some calculations from the JPL Horizons website, and I confirmed that if you were at the center of the Earth, the moon would have been up here north of the ecliptic, just like the sky and telescope diagram said it would be. But because of parallax, we were actually seeing the moon south of the ecliptic, which I mean, obviously I know that the moon's close enough. It has a discernible parallax, but I think this is probably the first time where I put 2 and 2 together and actually, was more or less able to see that, yes, the moon is not where the published information said it would be. So that was my eclipse observation. I'll open the floor up to that and any other observations from the past month or so.
John, one upcoming event to mention is the crossing of Saturn's ring plane. I think it's on March 23, 24, 25. So I think that Saturn's too close to the sun's glare to see it. But
Yes.
raise a glass or something, or salute the crossing of the ring plane, because I think the next one is 2039, and hopefully that's visible. I can't remember on my bucket list if I've ever seen the rings absolutely edge on.
Yeah, I'm looking here from last month. Saturn is at conjunction with the sun on the 12th. So, yeah, it's not going to be visible on the 23rd for the ring plane crossing. But I wonder what the latitude of the Saturn is. Is it going to be visible in like SOHO telescopic images of the sun?
Yeah. By the way, the clickbait media took the Saturn ring plane crossing and said, "Rings of Saturn to disappear." Yeah, they're going to
Right.
disappear while they're edge on. So, but
Yeah,
raise a glass when we cross the ring plane.
will do. How many people got up and watched some of the eclipse last night?
I live streamed the entire eclipse last night on YouTube.
Yeah, a lot of thumbs up. So good. A lot of people got out to see it. And how many people were there, Jordan? Okay.
Yeah, I think on Discord I saw that Wagman had maybe 50 people up there. If I read that right. Eric, did you hear anything about that?
I only knew about Matt Jones being there, but I intentionally did not publish "Don't come up, do come up," because I figured who's going to come up at 3 a.m. But apparently we did have a good crowd. So
Yeah, I think he left an email saying that there was about 50 people up there.
So I don't know whether he opened the gate and let them in or what, but that's fine. That's what the site's there for. By the way, Brian Crawford, did you guys, the changing subject for a second, did you get the double shadow transit on Jupiter the other night?
We did post a photo of it on Discord. It did make it to the list server, but yes, we did. It wasn't, the seeing conditions were very, very poor, along with our lack of skill set to do planetary imaging. But the image that we did produce off of the 24-inch, we were able to see it visually through the 10-inch. We were definitely able to see one. I think I did see a hint of the second one, but the seeing conditions were just not conducive for a telescope that size.
Speaking of clickbait, the other thing that's been in the news a couple weeks ago was seeing all of the planets in the evening skies. Of course, when they were hyping that, Saturn was already lost in the sun's glare, and Neptune, well, obviously you can't see Neptune naked eye to begin with, let alone when it's 10 degrees from the sun. But on February 28th, Katie and I went out to try for Saturn, the moon, which was 22 hours old, Mercury, and Venus. We did not see Saturn, but we did see the moon. I actually watched the moon set, and I could watch the Earth shine set behind a distant hill. We saw the moon. Mercury's been very prominent the last couple of weeks, and Venus as well. How many other people have gotten a chance to see Mercury?
Oh.
Few people have. Great. All right. Unless anyone has.
Yeah, hey John, another media excitement, or showing their knowledge. Yesterday on KDKA in the early afternoon, the radio, Marty Griffin had a meteorologist on, and said, tell us about this moon thing. And she tried to describe the eclipse coming up, and of course mentioned lunar eclipses happen when the Earth moves between the sun and the moon, instead of the moon moving behind the Earth.
Right.
So I just thought that was typical.
Yeah.
I was going to
And-
say,
and I got a brief look last night. I went out about 2:40, took a quick look, seen a bunch of these. It was a nice one, but I didn't hang out.
I was going to say, I was just checking the chat, and Ken had said that Priscilla and I are in Wisconsin. We had a very nice view of the eclipse here. And they said several times for Mercury that they've seen it. All right. John.
Oh, the Venus crescent is visible in binoculars. It's gotten large enough to be visible in binoculars, at least at 9x.
Yep. Not for, well, yeah, only a few more evenings, and then it'll be back in the morning sky.
All righty. John, as always, thank you so much for giving us the news. We'll go ahead and move on. And thank you, everybody that have been sharing their pictures as well. It's always nice to see what everybody's looking at. All right. Okay, so real quick, let's go over some officer reports. John, I know you were on. Do you have anything to report?
Yeah, I can just give the quick updates for programs that are coming up. So as Rich mentioned, this season of our meetings are completely booked up. So for the April presentation, we've got Dr. Matteo Luisi, who is an assistant professor of physics and planetarium director at Westminster College. And his talk is going to be on massive stars as a driver of galactic evolution. And then for our May meeting, we've got Cole Gregg, who is a PhD candidate at Western University in Ontario. And he's going to talk about some of the modeling and simulation he's done to see just how much debris from the Alpha Centauri system might have already made it into our solar system. And then, of course, we're off for the summer after that point. And we've got one talk that is tentatively penciled in all the way up in 2026. But otherwise, a lot of the calendar for next season is open if anyone wants to volunteer to give any presentations.
Yeah, I will, John.
Awesome.
All right. Thank you, John, as always. All right, Rich, do you have anything for recording and or VA? I know for VA you posted something recently on the listserver and Discord. Did you want to touch on that?
Yeah, nothing for recording secretary. For VA, started back up. Was out Tuesday night. Had some trouble with the scope not tracking, plate solving. It was way out of focus just from disuse and being cold, I guess. So I went back out last night, was able to get everything in focus and working the way it is. Going to try and have a mini star party, either this week or next week. Shooting for Tuesday night, but the first clear night that we can get out there. So I cleared it with the VA, and then I'll post definite on listserv and Discord when that's going to happen. A lot of the vets were asking when we're coming out again. They really, as any right-minded person, they really like looking through the eyepiece more than they like looking at a camera.
All right. Thank you so much, Rich. And as always, thank you for volunteering down there. I know they enjoy it, especially when we see the pictures.
Yeah.
All right. Next, we have Dave Rager for corresponding secretary. I don't think he's online unless Brian's giving him the phone or, oh, hi, Dave. There you are.
Hey, how's it going?
It's a
Uh-oh.
going.
I'm blank. What happened?
Oh, you hit the power button.
Oh, it's down. Oh, okay. The power button's on the bottom. Sorry.
Wait, where's Dave? Oh, sorry.
Did we lose it?
I was going to say, we can hear you. We just can't see you.
All right. That's okay. It's probably better that way. So, yeah, so we've been getting emails and responding and good questions and stuff, especially around events and things and people asking, if things are going on. And we have some questions I've forwarded to the executive committee and thanks to people like Rich and so forth that have jumped in to respond to folks. So, good stuff going on there. But since it's my turn, I do have something special that I want to show you. And as Brian and I were doing some stuff tonight, we actually met up with Dan, the guy who makes the globes. And we have something special to show you, which is this is one of the globes. This is, anyone want to take a guess?
You got to turn your camera on.
What?
The camera's not on?
The camera's not on?
No,
see it?
I just
Or
see.
share your screen.
Can you see now?
Can you see Brian?
We can't.
Yeah, we see a white truck.
No, we just see your Google image, Brian.
All right, hold that
Hold
thought.
on.
Technology.
Oh, the suspense is killing me, though.
We need the Jeopardy music.
For you folks on YouTube, this is what a well-organized club looks like.
Stuff happens.
All right. Well, we'll wait for them to pop back up. I don't even know if I could video call them, but we'll see if Brian's IT, he'll figure it out. Okay. So membership secretary, Gail, I know Patrick's on. Are you on? I know sometimes we can't hear you. If you want to use the chat, you can use the, oh, there's Brian. I see you.
Okay.
You still see us?
Yes.
Okay. Can you see this?
It looks like a white ball.
Here, hold it down.
Okay, it's blue.
Neptune.
Neptune.
That wasn't very scientific of you, Kristen.
So this is Mingo had Dan Andre commission the remainder of the 2 globes that we were missing for our solar system. And this is what he produced for us. There is only 2 in the world like this. One is at JPL and one is now at Mingo Creek Observatory. These are they're not paper, they're not vinyl. This is actually 3-dimensional. So if you rotate it, the features here, they are tactile 3-dimensional. We also discussed that he has Phoebe and Demos to complete our inner solar system if we are interested. And there was talks about pursuing a grant to replace our aging globes with this style, because these are much, much more expensive than the globes that we have currently.
I've never seen a quality of a globe like this. This is next generation for sure.
Yeah, so this was part of our budget that we approved, and I was not met with full enthusiasm whenever I told the committee the price of these globes, and we weren't expecting this. Dan went above and beyond, making sure we were able to get this. He had a few connections at NASA that was able to produce the globe, provide the model, and then the rest of it was hand painted to the detail and mapping from NASA.
So this is using the latest data that NASA has as far as the details on the planet. So, very good stuff.
Yeah, and there's only 2 in the world.
So with that, I'm gonna end my turn. I know we got to finish up, but I just wanted to show you that because we're kind of sitting here in the van waiting to, get through and because we got some stuff we got to finish up tonight, but we did want to show you this real quick. AKA a white ball.
Miss President, is it okay if I do my report real quick? Can I leapfrog?
Oh, I'm not supposed, not everybody is allowed, supposed to get special treatment and stuff like that, but sure.
To be fair, and I'll pull it up if you'd like, you did let others leapfrog previously.
It's okay.
Mingo update. Not really so much Mingo. I need astronomy pictures, and by me, I mean the club. I see all these pictures on Discord. That's great. If you wouldn't mind them being used for 3AP promotions, specifically me for printing postcards to hand out and give away. We need your photos. Mingo Director at 3ap.org. I've gotten 4 people to send pictures. Otherwise, Rich Dolish has said that he will gladly hand draw some sketches or use some grainy sea star photos for us.
And if that's what you want to represent the club, I mean, that's bottom barrel right there.
Hey, I heard Rich has some pretty good coloring skills. He does stay inside the lines.
But I see all these pictures, and I can appreciate if you want to keep some of your pictures for your own personal use. But please consider sending us. We need 25 pictures. That's all we need. We got like 5. So we don't have permission just to pull them and use them without your permission off of Discord. The only thing the club currently has is anything that's submitted through the astrophotography. But please, submissions to Mingo Director at 3ap.org. Beyond that, I just wanted to update on the globes. Mingo is just still working on the planetarium remodel. That's it. Thank you.
All righty. Well, thank you for the update. Thank you for showing us the globe. It'll be exciting to see it at Mingo. So thanks, guys. And we're gone. All righty.
Well, I'm still here.
Oh, okay. Can you mute? Thank you. All right, moving on. Okay, so I was asking Gail if she was on, and she is. So I got messaged in the chat. So she said the only thing that she is reporting is that the membership online application is still down. I believe Michael Scovern is aware of this. I was trying to look back through my phone to see where they were chatting about it. Gail had said it's a work in progress. She can still process applications manually. So if anybody, if you know of anybody that's trying to get a club membership that's having trouble, since if it's not working online, they can send an application to Gail's address, and the applications are available on the 3AP website. So if they go to the membership section of the 3AP website, they can print the PDF document for the information, and also they can send a check money order to Gail for membership. And hopefully we'll know soon once the website is back up. Heather, are you still online?
I am still here, yes.
Okay. Did I was trying to remember where the email, were you on that email at all? I just was curious.
What email?
I don't know if it was an email or if it was a conversation on Discord, but I couldn't remember if you were a part of it with the membership application or renewal online being down. Were you a part of it? Or I could be wrong. I just can't remember.
Was it like within the last few days?
Maybe or the last. Oh, Michael's on. I didn't even know Michael was on.
I was just hanging out waiting for you to mention like ask or the IT, and then I realized you didn't know that I was here.
I'm sorry.
Know is that the problem first showed up March 2nd is when Gail reported it. I don't know what is causing the problem. It kind of looks like maybe database corruption. I haven't been able to work on it to try to track down any more. As far as I can tell, it appears that we cannot do anything with the membership database. We can't add new people. We can't process payments. We can't add new members to the website. So, because that whole section of the Civi CRM just seems to explode in a software failure. So I'll update everybody when I can, but like I said, I have not had a chance to really dig deep into this one yet, and it's a tricky one. That's it. All I can say about that one.
Okay. Again, I apologize. I didn't look at the people's list, so I didn't see that
She
you
says
were
she's
on.
able to add memberships, but I don't know how you can add a membership without adding a. I'll have to ask. I've been able to add memberships, but not individuals. I don't know how you can add a membership without adding an individual because you have to attach a membership to an individual. So
maybe renewals.
Oh,
Yeah. Yeah, she has in the chat, I have been able to add memberships, just not individuals for family memberships.
Okay. Maybe something started working better because as soon as you go to the page to add a new person, it blows up for me. So like you can't put a new I don't know how you can. Yeah, you can't add individuals for family memberships, but you can't. I'm not able to add any type of a individual at all.
So are you talking about like the individual person records versus updating the membership on an existing member?
Yeah. Well, yeah, you might be able to, like I said, anything involving contacts and contributions blows up.
Well, she's saying renewals are fine in the chat.
So it just is, I don't know what's going on.
Okay.
It's not good.
Was the database was Civi CRM updated?
I'm not going to change the code. Nothing's been changed.
Well, no. If you look at the link that I had provided for the Civi CRM update, there was something about that the database schema changed for contacts.
But I didn't change the software. The software has been, I think the software was last updated like in January. And so no changes have been made. There were no software changes made. And then all of a sudden on March 2nd, it died. On March 2nd with no changes, it died. So that's not, so something else changed in the system and it wasn't the code. And
could it be any of the WordPress plugins? Because we know we have issues with those.
It could be, but nothing changed in the time frame of the breakage. So that's why it's been a really tricky problem, because I know exactly when the problem first started. March 2nd around 9:30 p.m. The first indication of the error occurred like 2 or 3 minutes after Gail logged in. That was the first time that the error, and it's been happening ever since. So my suspicion was something prior to Gail's login changed. That was the first time she tried to do an update. It failed, but now it's happening. Like I said, the logs are it's just constantly reporting in the log failures. So But I haven't had a chance to work on it. So,
quick question. Was it around that same time that we had the issues? Or no, maybe it was into February. Whatever the script was that authenticates against Discord. I don't know how any of that.
yes, it was in the same time frame. Yes, it was it was in the same range of days. Within a day or two, the Discord had the same problem within a day or two. However, I think there was an explanation for the Discord authentication. Thinking back, when I first saw the problem and I first started working on the problem, I was cleaning up some things, and in the process of trying to fix the membership problem, I inadvertently changed permissions on a Scratch directory, and that Scratch directory was needed by Discord. So Discord was failing, but we know why it was failing. It was failing because I accidentally changed permissions and locked it out. So, but we fixed that. So they weren't related. I mean, in the same time frame, but that one's been explained.
May I suggest that we continue the discussion at the executive meeting?
Yeah, we should move it off this.
Yeah, I agree. We will definitely discuss that, and just keep us updated. And the rest of us, if we know of anybody, friends or family that are having issues, then at least we know that you're working on it, and you'll let us know as soon as you know what's going on. So
exactly.
When is the exact meeting again? Did you send out an appointment for it?
Yes, March 24th, I believe, the Monday.
Okay, I don't know why it's not on my calendar. I'll check again. Thank you.
Yeah. All right. Go ahead and move on. Oh, thank you. Oh, I think Chuck's. Hold on, let me mute him real quick. Let's see. Okay. All right. Sorry about that. Okay. Terry Mealy. I believe he was on earlier. Are you still on?
I'm here.
All right.
Yeah.
Do you have any updates for us?
Nothing special to report. I'll get the treasurer's report. The first quarter treasurer's report done at the end of the month.
Okay. Sounds good. Thank you. All right. Michael, did you have anything else that you needed to touch base on? I'm sorry, we jumped ahead, but that was because I didn't know you were on. I apologize.
The only thing that I'll say is that I have to work with Terry and try to figure out how to initiate moving the phone number for Wagman out of Verizon and into Amazon Chime for our new voice VoIP system. Haven't had a chance to work on that with him yet either, but that's a to-do item that we want to get done soon. We got to get the phone working up. I mean, we have a working phone, but we got to get the phone number.
I'll work with you on that. Be nice to close down the account.
I'm sorry, what was that?
I said I'll work with you on that. It'd be nice to be able to close the account.
Oh, yes, right. Yep. Thanks. That's all.
All right. Thank you, Michael. And thank you again, Terry. I saw Joyce was on early. Is Joyce still on?
I'm still here.
All righty. Do you have a report for us?
Well, nothing new to report. I would just ask if John Winskovich could send me information about the speakers for the next couple of meetings.
Sure, will do.
Okay, thanks lots.
Yeah, for that, sorry, I'm jumping in. Yep, sorry, I'm jumping in. John and Gail, or I'm sorry, John and Joyce, we are going to start using that social media requests distribution group again. We used it a few years ago and it worked really well. So everyone that needs to update things, not just GuideStar, but like Facebook, for YouTube that John Stump uses, like anything that we need to publish this information on, all of us will be on that distribution group. So more details to come.
Thank you.
All
Sounds
right.
good.
All right. Thank you, Joyce. All right. We'll go ahead and move on here. All right. So I went ahead and pulled the database. I did see that we had two. Now I just checked the chat, and we have a member that said that they were able to sign up for a family membership on 3.3 and everything seemed okay. So Bob, are you still on?
Yeah, there were a couple of emails that I could see that there was some traffic on the website.
Yeah.
But as I worked on the website, I did start to see things look like they were getting worse. And then given that I didn't know the state of how bad the database corruption was, I took the external page down to stop external signups because I didn't know if it was going to work or blow up.
Right. Yeah. No,
So
that's
yeah,
fine.
some of them look like they might have worked, and things seem to be like partially working.
Yeah. No, that's fine. I just I went on probably 10 minutes before the meeting to pull the names. So these were the two names that had come up that so I think these ones were in February, maybe like February 27th was one of them. I know for sure. I don't remember the other one, but Bob just said that he joined 3.3. And I apologize. I know a lot of names and I know some names. Are you a new member or have you been in the club before?
Yeah, I have been in the club before. Haven't done a heck of a lot, but I did sign up again. I guess I had missed the membership date, and so I reached out to Eric, and then I was able to go online. About the same time, I was emailing Eric and Gail, and I used the website, and it seemed fine.
Okay. Well, that's good. I'm glad you were able to get back with the membership with us. I just wanted to make sure I didn't miss you, just in case when I was pulling the data off. So I was going to be like, I'm sorry if you are a new member and your name's not on here. So, but anyway, the two new members that I did pull is Connor Kirkland and Doug Wagner. And can I get a motion to accept those two members pending? We may have more member names coming in April. I think Rich went first, and I don't know who the second one was, and I just see a bunch of thumbs up. Sorry, I did see Rich go first. So I'll take Rich as a first motion. Do I have a second? John, I
I'll
see your-
second. John
Oh,
Holtz.
John Holtz. Okay. All those in favor?
Aye.
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 Yeah, Gail and Kristen. I know John Sheldon called me the other day, and I think his membership lapsed and he wants to renew, but he was
Okay.
having trouble doing. I think he's just going to come up to the first Wagman Star Party and probably hand Gail money in person.
Okay.
Refill out the thing because he's not a good computer person. So
Okay.
but yeah, he called me. He said, "Oh, I have a new telescope." You know, so we get pictures of it. Okay, come to Wagman. So
Okay. All right. Were there any objections? Any abstains? All right. Motion passes. We welcome Connor and Doug into our wonderful organization. I do not know if they're on tonight, but hopefully we will meet them soon at a star party or another event. Yeah, I don't think I see their name on here. Okay. All right. So as of now, from what I gathered tonight, I don't know how right this is, but it was giving me a total of 348 members. So that is where we're at right now. Okay. we're going to go ahead and move on to the observatory reports. Brian, he told me, unless something changed, but it doesn't look like he's still online. But he didn't have anything. So Eric, I'll turn this to you if you want to give us an update.
Okay, I know, I'm looking at the clock here. It's almost 10 o'clock, so I'll make this very quick. We had our first major work party at Wagman in maybe 20 or 30 years. I had 8 or 9 people show up. We pulled the rug from the Brashear room, and the damage to the floor became more obvious, the water damage. We put a plastic tarp around the Brashear telescope, so we are now ready to have a carpenter come in and repair the floor. We generate sawdust. The telescope is protected. We have picked a contractor. We're just awaiting executive committee and Allegheny County approval, which shouldn't be anything. And I told the contractor already to set aside some space for us. He thinks it'll take about a day or day and a half to repair the floor. When we pulled the rug, of course, we created a giant cloud of dust because it's all the glue on the back of the rug just disintegrated over 30 years. I'm going to I'm going to get a couple estimates for a carpet company to put a new floor, a new rug in the Brashear room. So with enough people out there, we decided to start going into the back storage room. Now, if you've been to Wagman, that room is only about as wide as a person. Despite that, we pulled out, it was like going into a closet in the Carnegie Museum. We pulled out a mountain of junk from there, like the box that the Brashear lens was stored in, and a half-inch, 11-inch mirror blank. And that's going to go one way or another. We're not keeping stuff there for museum purposes. I think what I'm going to do is I'm going to have a GuideStar supplement, or Joyce will have a GuideStar supplement coming out, where some of the stuff we will offer to the members, it's there for the taking or for a donation, a generous donation to the AAAP, take away some of this old gear. And if you go up to Wagman, it's a mess right now. The reception room is full of junk. You can't move around very much. The goal is to be open for the April 5th Star Party, at least for the 21-inch. It's possible that we won't be ready with the Brashear room. We'll just put a sign on the door that says closed for remodeling, but we're still hopeful. But again, watch for this GuideStar supplement on junk, good junk that we found in the closet. That's it.
Thank you.
All right, thank you, Eric. Real quick, Heather, I apologize. I shouldn't say I forgot, but I didn't know if you had anything you wanted to report for Mingo. I know I jumped and said Brian told me everything was good, but if you had something, I'm sorry if I didn't mean to skip you.
No, I don't have anything.
Okay. All right. Thank you. I'm sorry. All righty. So moving on. So old business. Brian touched base with this already whenever he called in. Just a reminder, 3AP will be at NEAF in April. If you are okay with sharing pictures, please send them to the Mingo director's email address for the 3AP. Again, the 3AP events are on the club calendar. Please let us know if there's anything that needs to be added with offsite star parties or any events that we've attended from before. And also just reminders that the club membership renewals were due. So there may be some people that are coming out of winter hibernation and they're like, oh, it's time to get the telescopes out because it's not, negative 10 degrees outside. So let them know that, make sure you let us know if you are going to be renewing. So for new business, it's hard to believe that we're coming up on nomination time. So elections for office, for the officers are going to be in May. So I know it's hard to believe. So for tonight, the only thing that I had was to give a nomination for a chairperson for the nominating committee. And as president, I decided that I would like to nominate Rich Dolish for the chairperson for the nominating committee. Rich, I'm sure you're still there.
am.
Would you, would you
Wait a
accept?
minute. I don't believe you can have a sitting officer as the chair of the nominating committee.
You better look in the
That's-
bylaws.
I don't know about that because the past ones were always officers.
Yeah, I was gonna say,
It was always past nominating chair for many, many years was Bill Yorkshire, and he's an officer of the committee.
Well, yeah, if you're counting the directors, well, then never mind. I'm just thinking of the line officers.
John, do you have anything being, or Ken, as past president?
I'll see if I have the current bylaws.
I was gonna say I can look them up real quick. Just take me a second.
It's a race.
Yeah, it's a race. But I can look.
Any
I
member
haven't-
in good standing may recommend a nominee to the nominating committee. That's for the election officers. I'm not really seeing anything.
Yeah, to
I
my
was gonna
knowledge, I
say-
don't remember seeing anything to that effect, and it's always been somebody that sat on the executive committee before.
Yeah, I was gonna say, I'm pretty sure the only thing in the bylaws is that the president does the nomination for it, but I don't remember seeing anything that they can't hold a position or can't be a current officer.
At the regular
I-
March meeting, the president shall appoint a chairperson of the nominating committee. 2 other members in good standing shall be nominated and elected by the membership present to serve with the chairperson.
Yeah, so the way I always understood it and the way that is read, the appointment is by the president. There's no vote needed for that.
Yeah. Yeah, so I believe we're okay, Joyce.
Well,
Maybe
it just seemed that somebody that was potentially running for office shouldn't be on the head of the nominating committee, but that's the Robert's rulesy things. But if it doesn't say anything in the bylaws, that's it.
Okay. All right. I'm gonna go ahead and still go forward with my nomination. Rich, are you accepting my nomination?
I will. For what it's worth, with using the electronic service that we did last year, there's absolutely nothing that the nominating chairperson does other than fill in the information online. I have no control over the ballots or over the votes. I couldn't even see who voted for who. So it's all done with the I can't think of the name of the service we used last year, but very easy to do and very up and up. So I do accept. Yes, thank you.
Okay.
Rich, would you check to see if that service needs to be renewed?
Yeah, it'll be about $100. I'll double check to make sure the price hasn't gone up.
Thank you.
Election
Okay.
Buddy, that's what it was.
Yeah, I was gonna say, I think that's what we used last year. All right, so, Rich, I believe, and I think in the past, we've had two members that have been a part of the nominating committee as
Yes.
well? Okay. Do you have 2 individuals that you would like to ask, or you would like to recommend or have be on the committee with you. Sorry.
Brian Luis did it last year. If anyone would like to join, just shout out, but Brian and Luis would be fine if they're interested again. I know Brian's neither one are online, so if anyone else is interested, please reach out to me.
Okay. Is anybody online want to volunteer? No? Okay. I'll since you mentioned Brian, I'll say something to him whenever he either calls or whenever he gets home. Luis, I haven't talked to him in a while, but I'm sure if you message him on Discord, or if anybody else who just couldn't attend the meeting tonight, if they're interested, reach out to Rich as well. Preferably, I would say before the April meeting, Rich, just let maybe put a message out to let us know who's a part of that committee. Okay.
I'll take care of it.
Thank you. Much appreciated. Sorry, I muted myself. All righty. I think that's all I had for tonight, which is kind of a good things we ran over. Does anybody else have anything that we need to discuss, or any other quick issues, topics? No? All righty. So our next meeting will be April 11th, 2025. Again, John had already said this. It will be with Dr. Mattia Luisa from Westminster College. That's actually my alma mater, so I'm really excited. I was in contact with him. He's a really nice guy. I think he's going to give a really nice presentation, so I hope you all join us in April. It will be online only. I'm still trying to book somewhere for May. I have to get in contact to see if we're going to do it at Allegheny Observatory or if we're going to find somewhere else to meet. But with that meeting in May, it will be in person and also online. So I will keep everybody in the loop. I would definitely just, if you want to attend the meeting, definitely make sure you book the second Friday in May. I don't remember what the exact date is. So may I get a motion to adjourn the meeting tonight? Patrick, I see you have your hand up. May I have a second? I think Terry had his hand up. I have a lot of hands are going up, but I think I saw Terry Mealy's hand go up. So I will take that as the second. Are all those in favor? Aye, thumbs up.
Aye.
Aye. Are there any objections? Any abstains? All right, meeting is adjourned. Thank you all so much for joining tonight. Sorry it went over. Hopefully everybody who stayed up last night gets some sleep. I am definitely tired. And John, also let us know when the next date is going to be for quaffing. Thanks again for hosting it at Olive Garden. We all definitely had a good time, and food was yummy. So, keep us in the loop. Let us know where we're meeting next. All right.
We'll do.
Sounds good. All right, I'll keep the meeting open if anybody wants to talk. Thank you again for joining. I hope you all have a great night, and thank you to everyone who joined us on YouTube. I hope you enjoyed, and if you haven't already, make sure you hit the like button and subscribe. Thank you very much.